Hi, welcome to my channel. In the previous videos, we discussed about the definition of decision tree. That is what is the decision tree. Okay, what is the decision tree and what are different types of decision tree algorithms? Types of decision tree algorithms. Okay, like we're having the different types of algorithms like ID3 algorithm and C4.5 algorithm and CART algorithm. These are the three different types of algorithms are there. And also we discussed about the how to train the decision tree algorithm. That is a training and visualization of decision tree. Visualization of decision tree with the help of our CART algorithm. And also we discussed about how to make estimating the class labels, estimating of class labels for the given instances, and also we are making the prediction for the class labels with the help of our algorithms. Now in this video I am going to explain about the classification of iris flowers using the decision tree classifier. The algorithm we are going to use here is a CART algorithm. That is internally it uses the concept of GINI index value. Okay. Now, so here we are seeing the one data set, that is a standard data set. So that is called as a iris flower data set. It internally contains the four features, that is a sepal length, sepal width, petal length and petal width. These are the features of the iris flowers, and the corresponding class labels are, this is called as a species. Like it contains three class labels are there, like iris setosa, and iris Virginica and iris Versicolor. These are the three class labels are there. That means the data contains the combination of x and y. X nothing but features like sepal length, sepal width, petal length and petal width, and the corresponding y nothing but is class labels or target variable. It contains Setosa, Virginica and Versicolor. Okay, based on the features we are having the three class labels. So totally it contains 150 rows and 5 columns. Based on this data set, we are going to apply our model. That model is called as a decision tree classifier. We are going to construct the decision tree, and also we are making the corresponding class label for the given data set with the help of some algorithm. That algorithm is called as a CART algorithm. CART means classification and the regression tree algorithm. It internally uses the concept of GINI index value or GINI impurity value. Okay. Now we are going to see the procedure to solve the problem with the help of this machine learning algorithm. Okay, this CART algorithm. Now in order to construct the decision tree with the help of machine learning process, we have the different steps are there. The first step is understand the business problem. So the problem is here is classification of iris flowers. Okay, using the decision tree algorithm, decision tree classifier. So that internally uses the algorithm called as a CART algorithm. CART means classification and the regression tree algorithm. Internally it uses the concept of GINI impurity. Okay, so that is your problem. So here we require the two things. One is the iris flowers, and also we require some algorithm. That algorithm is called as a CART algorithm. So our aim is we have to classify the given data into different class labels. Okay, so that is your business problem. Now collect the data set. For in order to perform this operation, we require some data set. That data set is called as a, here we are going to import the data set is called as a iris flowers data set. Okay, so there are different approaches are there. So like this is a universal standard data sets. That's why this data set already kept in our Scikit-Learn databases. Okay, from that also we can import the data set. Otherwise we can import from the different sources like Google it or Kaggle or some GitHub sources. We can import the data set. Okay, and then we are placing that data set in our Google Drive. Okay, our Google Drive. So in order to better access our data set, then we have to perform the different pre-processed steps on the given data set. That means, suppose here we are having the data set, that is iris flower data set. If any columns are there missing in the data set, we have to perform the pre-process the data set. This is the best first step you have to perform on the data set. Okay, so you have to perform different operations, like you have to identify whether any missing values are there, or whether it contains outliers are there. Okay, and also you can perform the different normalization of techniques, like standardization, normalization techniques, so that you can get the good quality data. Okay, on that good quality data, we are going to perform the our machine learning steps. Okay, so then we have to split the data into training part and testing part. So that means here, after performing the pre-processing the data set, okay, we get the standard data set. On the standard data set, we are going to divide that into two parts, that is training and testing part. So here we are having the sepal length, sepal width, petal length, and petal width, the corresponding species. Species. This is your data set. Okay, now these are called as features, and this is called as your class labels. So it contains 150 rows are there. 150 rows are there. Now randomly, okay, this is your data set. Now here the data set divided into two parts. One is training part and testing part. So that means the data set divided into two parts with the help of our data. So here 70% of data is given for the training, and 30% of data is given for the testing. So there are different approaches are there. One is 60% given for the training, and 40% is given for the testing, or 75% is given for the training, and 25% is given for the testing. So there is no standard way, but we can give the normally 70% is assigned for the training, and 30% is given for the testing. Okay, so this part is called as a x_train. X_train. So this is called as a x, and this is called as a y. All the features are called as a x, and species are called as a y. So now the 70% of data is assigned for the x train. X is assigned for the x train, and the corresponding class labels are assigned for the y train. Okay, and also the remaining data is assigned for the x test data, and the corresponding y labels, target labels are assigned for the y_test variable. So this is the actual data. So x train, y train, and x test and y test are called as your actual data. Okay, so this is called as your splitting of data into two parts, that is training and testing. So the data is divided for the training and testing. Okay, so here the 70% of data is randomly picking the some points out of 150 rows, randomly picking the for the training purpose. Okay, 105 rows are assigned for the training purpose, and remaining 45 rows are assigned for the testing purpose, randomly. Okay, we are not select the sequential manner, we are selecting the data in the form of a randomly. Okay, randomly. So like that we are assigning the data for the training purpose and the testing purpose. Then develop your model. So here the model is we are going to develop our model is called as a Decision Tree Classifier. So here our model is a Decision Tree Classifier. Decision Tree Classifier, that is internally available in the Scikit-Learn.tree class. In that we are going to import the Decision Tree Classifier. Internally it uses the concept of CART algorithm. That means the criteria we are going to use is GINI index value. So here we are applying the concept of our model equal to Decision Tree Classifier. Okay, Decision Tree Classifier. In that we are providing the criterion equal to GINI value internal. Okay, that means okay, there are different types of hyperparameters are there, we will see later, but the main criteria equal to GINI, that is the main hyperparameter is going to use it. Here is a GINI index value. So based on this information we are going to build the model. That model is called as a Decision Tree Classifier. Okay, now that is our model. Then train the model using the training data. So here the model is going to be we have to train the model. Okay, now for this we are going to apply the concept of a model. Okay, model dot fit function. For the fit function, we have to provide the x train and the y train data. Okay, so that means x underscore train and corresponding y underscore train. That means here the function is there. That function that is called as a decision tree classifier. Decision tree classifier function that trains the establish the relationship between the x underscore train underscore x underscore train and corresponding class labels y underscore train. So it establishes the relationship between features and the corresponding class labels. So like that we are going to train the model and then test the model using the test data. Now we have to provide the next step is we have to predict the class labels. We have to predict the class labels prediction. Okay, with the help of model dot predict. Okay, so model for this model prediction of new data. Okay, you have to give the x test data. For the based on the x test data, we are going to predict the class label. Okay, we are going to predict the class label. That is simply discarded as y cap. Okay, y cap equal to model dot predict. So this y test is called as your actual data and y cap is called as your predicted data. Now based on these two variables, we are going to estimate our performance of the model. That is called as evaluate the performance of your model. So here we are having the y test, that y test is there, y underscore test value is there, and also we are having the y cap values are there. Y cap is nothing but your predicted value, okay, and y test is nothing but your actual value for the your x test data. So now there is a we are comparing the difference between the y test and y cap value. So that is okay. So with this information, we are going to find out the performance of the model. If y test equal to y cap, that means predicted value both are same, then the accuracy of the model is equal to 100%. So like that, we are going to find out the performance of the model. So here we are having the one matrix is called as confused matrix. Based on confused matrix, okay, confusion matrix is there. We are going to connect the confused matrix. Based on the confused matrix, we are going to perform the performance, find out the performance of the model. So with this help of there are different types of performance measures are there, like accuracy, okay, precision, recall, and F1 score. These are the different performance metrics are there. Based on these performance metrics, we can estimate our model performance. Okay, so these are the steps you have to carry out during the execution of our model. Okay, in the machine learning. So now we are going to see these steps with the help of some Python code. Okay, so here we are having these are the different types of flowers are there, like iris Setosa, iris Virginica, and iris Versicolor. Our aim is if you are giving the any flower data, like any flower features like f of sepal length, sepal width, petal length, and petal width, we have to estimate the corresponding class label. You have to map that into any one of the class label. Okay, so that is our aim. So we are going to see the code for this problem statement. Now here, first of all, we'll see what is the decision tree classifier. Decision tree classifier. So here, the Scikit provides all the machine learning algorithms. Okay, they inbuilt. They develop the code and they built one API. Okay, that is called as a Scikit-Learn. Okay, so we are using our model called as a decision tree classifier. That is a class sklearn tree dot decision tree classifier. This is our model. So now we are having the different types of parameters are there in the decision tree classifier. That is a criterion equal to GINI value and splitter equal to best, max depth equal to none, and min underscore samples underscore equal to min underscore samples underscore leaf equal to 1, min underscore weight underscore fraction underscore leaf equal to 0.0, max underscore features equal to none, random underscore state equal to none, max underscore leaf underscore nodes equal to none, min underscore impurity underscore decreases equal to 0.0, class underscore weight equal to none, CCP alpha underscore alpha equal to 0.0, monotonic underscore CST equal to none. So they are the different hyperparameters. Now we are going to apply. They are the default values. So suppose you want to get the best results, then we have to change the fine tune these hyperparameters. You can adjust these values to get the best results. So here the main thing is here in our problem we are applying the GINI index value, that is CART algorithm. So in order to implement the CART algorithm, we require the criterion equal to GINI value. So here the criterion equal to GINI value, entropy and log loss. So here the default value is equal to GINI value. Automatically it implement the CART algorithm. So that is the major difference. Okay. Now we'll see step by step process of this problem statement. Okay. Now our aim is the implementation of decision tree CART algorithm using the Scikit-Learn. Okay. So here you are using the GINI index value. Now we are having the different steps are there, already we discussed. So the first step is importing the library files, then reading the iris dataset and pre-processing, splitting the data into training and testing part and build the model. The model is here is a CART algorithm that internally uses the concept of GINI value and evaluate the performance model. Then we are going to visualization of our model. Okay. So here we require some important library files are there. So those are import NumPy as NP, import Pandas as PD, import Matplotlib.pyplot as plot PLT, and import Seaborn as SNS. And these are some of the these are the used for to analyze to perform the mathematical operations. And also we require some data set here, that is from Scikit-Learn import to dataset. Our dataset is iris dataset, so that is a standardized dataset. That's why the dataset is kept in the datasets. Okay, Scikit-Learn. So from that dataset we are going to import our dataset. Okay. From Scikit-Learn.tree import the decision tree classifier. Our model is a decision tree classifier, that is imported from the Scikit-Learn.tree. And then we are going to import the one more thing is called as a train underscore split, train underscore test underscore split. This class is used for to split the data into two parts, training part and testing part. So that is there in the from Scikit-Learn.model underscore selection. We are importing from import the train underscore test underscore split method. Okay. So like that we are going to import all the library files, important library files. Then the next step is reading the iris dataset. So here from google.colab import to drive.mount /content/drive. That means our dataset, we are download the dataset and that dataset is kept at our Gmail okay drive. So that is available permanently in our Gmail, okay, Google Drive. So from that we are going to import the getting the access from the access the dataset. So that's why we are going to connect the from the Google Colab to, we are going to establish the relationship between the connection between the Google Drive to Google Colab. Okay, so that is required drive.mount to content to and drive. Okay, so this is establish the connection between your Google Drive to or Google Colab. So from that we are going to import the data. So that is iris equal to pd.read underscore csv. So our data set is iris.csv, that is there in the content/drive/my drive/iris.csv. So we are reading the data set and place in the variable that is called as iris. Now we are going to display the iris shape of the iris. Okay, that is print iris.shape and print iris.head. It displays the size of shape of the iris powers, that is 150 rows and 5 columns are there, and it displays the top 5 rows of the corresponding data set. So the features are sepal length, sepal width, petal length and petal width. The species are, this is the Setosa one. The top 5 rows species are Setosa one. Okay, so now we are going to display, suppose you want to display all the top 5 rows and the bottom 5 rows, just to simply type the iris. So it gives the sepal length, sepal width, petal length and petal width. The species, it displays the top 5 rows Okay, 0, 1, 2, 3, 4. These are the indexes of the data set. Okay, instances that starting with 0 only. Okay. Now these are the top 5 rows, and bottom 5 rows are 145, 146, and 147, 148, 149. Like that, we are going to display all the things. So the total shape of the data set is 150 rows and 5 columns. Okay, 5 columns and 4 are features and 1 is class label. Then print the iris data species. Now we are going to display the corresponding target variable, that is a species only. It displays the top 5 species labels like Setosa. Okay, bottom 5 species labels like Virginica. So this is the display print of the corresponding species. So here it contains the name of the target variable is species only. The length of that one equal to 150. That means it contains the 150 instances are there. Okay, class labels are there, and corresponding data type equal to object type only. Why all these things are in the form of a string character? That's why it displays as a object. Okay, and then iris.info. It displays the we are going to get the full information about the corresponding iris flower. So here we are getting the sepal length. It contains 150 instances are there, and all are non values. The type of the data is float to 64, and all like that we are going to display all the things. And species contains 150 instances are there, and all are not non-null values and object. So by seeing this one, we can estimate that there is no missing value. Why? All the columns are filled with some data, that is 150 instances are there. Okay, so there is no missing value, and then we can directly go for the pre-processing. This is a simple data set. That's why you are going to apply a normal pre-processing steps here. Okay, the next step is pre-processing. In the pre-processing, we are going to import here we are performing the we are applying some concept called as a label encoder. That label encoder automatically convert the class label that is in the form of a character that is converted into numerical values. Okay, so here from the Scikit-Learn import pre-processing, that pre-processing contains the label encoder. The label encoder automatically convert the labels, or what we are having like here we are having the Setosa, Virginica, Versicolor. Okay, all these are converted into numerical values. So that means L equal to pre-processing dot label encoder. So then label encoder dot fit for the entire our target variable, that is iris dot species. Now we are going to okay, then whatever the conversion are there, that is applied for our entire data set, that is reflected in our data set. So that is iris iris species equal to LA dot transform iris dot species. Whatever we converted that into numerical value, that is reflected in our original data set. Okay, so print iris and print iris dot species. So here if you print the iris flowers, so sepal length, sepal width, petal length and petal width is there, and species also there. Previously we are having the corresponding class labels in the form of a Setosa, Versicolor and Virginica. Now we are representing the form of a numerical values, that is 0, 1, 2 like that. Okay, and if you display the only iris data species, we are having the 150 rows or 150 column. Okay, things 150 names are there. These are represented in the form of a zeros. Okay, zeros. So the name of the species is column is species and length equal to 150, and the type of data set is type of the corresponding column is into 64. Previously it is in the form of a object. Now okay, that is in the form, now we convert that into integer format. So if you want to perform any mathematical operation, it is not possible to apply the mathematical operation on the object type. So that's why we are going to convert that into numerical form. So that is here we are applying the label encoder. So like that we are applying the pre-processing. Now then we are going to divide the data into two parts now. That is basically x variable and target variable. Okay, that is features are belonging to one variable and corresponding class level belonging to one variable. So so here we are deciding the two variables, that is x and y. So x is nothing but your features. So we are storing all the features in x variable. Iris dot I location colon comma 0 to 4th. That means the index of that column equal to start with 0 only, 0 from the 0 to all the all the except the fourth column, that is 0, 1, 2, 3. Except the fourth column, all are placed in the x value. So if you display the x value, okay, we get the only features only. Features sepal length, sepal width, petal length, and petal width only. Like that, we are going to display the get the all the values of x. Okay, then y equal to iris dot to iLocation, and we get here we require the only class label, that is a species only, that is at index value 4. So now y equal to iris dot to iLocation, all the rows comma fourth column, fourth index value. So it displays it contains only the corresponding column only, that is a y y species only. Now if you display y value, you get the all corresponding column, single column only. Okay, it contains 150 rows and 1 column. Okay, then that is the like that we are going to divide the data into x and y. Our next step is we have to split the data into x train, x test, y train, y test. This is a very important step in order to perform the training the data, training the model, and test the model. So here x underscore train underscore x underscore train and comma x underscore test, y underscore train, and y underscore test equal to, here we are using the method called as a model called as a train underscore test underscore split. For that we are providing the corresponding class features and corresponding class label, and the training size equal to 0.70. Okay, and random state equal to 101. So that means the data set is divided into 70% for the training and testing, 30% for the testing, and randomly we are assigning the variable for the training and testing. Okay, so if we display the x test shape and x train shape and y test shape and y train shape, so here this is 45.4. that means 45 rows are for the assigned for the corresponding x test, and 105 rows are assigned for the x train, and 45 rows are assigned for the y test, and 105 rows are assigned for the y train. Okay, so here 4 and nothing but 4 features and 1 nothing but 1 corresponding column. Now we are going to build the model. The model is you are going to use the model is a decision tree classifier. Okay, it internally is the concept of criterion equal to GINI value. Already we discussed the model. Okay, so our model is Scikit-Learn tree decision tree classifier, and the criterion equal to GINI value. So GINI value nothing but internally we are implementing the concept of CART algorithm. So decision tree classifier criterion equal to GINI value, and we are going to fix the depth of the tree, that is equal to 2, and the random set equal to 1, 2, 3, 4. Like that we are define our decision tree classifier. So and then we are going to train the model. Okay, for the training we are providing our model name. Model name is equal to classification underscore train dot fit method. Okay, by using the fit method we can train the data. So for the fit function we are providing the x train and the y train. Okay, and then based on this information we are going to train the model. Our model is now train decision tree underscore train. Now based on this information we are going to predict the corresponding class labels. So for the y prediction, that is we are going to predict the class label for the new data, that is for the x underscore test. So decision tree dot underscore train, or model is decision tree underscore train dot predict the class label for the x underscore test. Now if you display the corresponding y underscore predictor values, so there is sum of the class labels, corresponding class labels like 0, 1, 2, like that. 0 nothing but Setosa, 1 nothing but Versicolor, and 2 nothing but Virginica. Like that we are going to find out the corresponding class labels. Now this is about the display of all the 45 class labels. Now if you display the top first 10 class labels, predicted class labels, so y underscore predictor of starting with 0 to up to 9 up to 10 index predictor values, 0, 0, 0, 1, 1, 2, 1, 1, 2, 0. So this is your predictor values. Okay, so that means 0 nothing but Setosa, 1 nothing but Versicolor, and 2 nothing but Virginica. Now if you compare the actual y test value, the actual y test of 0 to 0 colon to 111 means we are displaying the first columns here. Okay, so here the corresponding features class labels are 0, 0, 0, 2, 0. So if you see the the first value of the actual test value, the predicted value, both are same. So like that we are going to compare the things. If both are the same, the accuracy may be high. If both are the different, we get the different accuracy. Okay. Now we are going to construct the decision one matrix called as a confused matrix. Okay, that is there in the Scikit-Learn. We are going to import the matrix from the okay, Scikit-Learn. So import Scikit-Learn dot matrix as matrix. Okay, from the matrix, okay, we are getting the confused matrix. So confused matrix equal to matrix dot confused underscore matrix. Okay, for that we are providing the actual data and the predicted data. So actual data is called as a y true data, y underscore true equal to y test data. This is your actual data, and the predicted value equal to y underscore predictor equal to y underscore predicted value only. So we are going to construct the confused matrix with respect to actual data and the predicted value of testing data. Okay. Now here we get the, after execution of this statement, we get the one matrix, that is a 3 by 3 matrix, and the first row contains the rows are belongs to the actual value, and columns are nothing but predicted values. So here 13 Setosa class are there, 13 are correctly classified as a Setosa only, and the second row totally we are having the 20 versicolors are there, and out of 20 versicolors, 19 are correctly classified as a versicolor, and 1 is classified as a Virginica. And in third row is represented as a Virginica. Out of 12 Virginica class levels are there actually, but our model predict as a 10 as Virginica and 2 as a Versicolor. That means out of 45 instances, 3 are wrongly classified and the remaining 42 elements are correctly classified. So if you see the diagonal values 13 plus 19 plus 10, these are correctly classified, and 1 plus 2 are wrongly classified. So based on this information, the accuracy of this model is 42 by 45. That means 42 are nothing but correctly classified elements by the total number of elements, that is 45. Okay. So like that we are going to predict the corresponding performance of the model. So now we are going to evaluate the performance of the model. So first of all, we are going to find out the performance of the model with the help of our training data itself. Okay. So for that we are going to find out the print the score of the each one. Okay. Print to decision tree dot score of the x train and the corresponding y train, and print the training data on the decision tree dot score on the x test and y test. So here during the training data we get the 0.97 accuracy is there, and for the testing data we are having the accuracy is 0.933. Okay, on the training data also we are having the accuracy is 0.97, but testing data also we get the output as a 0.933. Okay, then we are going to display that in the form of a confused matrix report. So class wise we are going to display the report. So matrix data classification report. For that we are providing the y train and y true equal to y test data, comma y predictor equal to y predicted value. So print the class wise report. So precision, recall, F1 score, and the support is there. So here the class 0 corresponding precision equal to 1.0. That means class 0 that what is Setosa, and recall equal to 1.0, F1 score equal to 1.0, and support equal to 13. Here 13 nothing but out of 45 instances, okay, 13 are belonging to Setosa only. Okay, Setosa, 20 are belonging to Virginica, and 12 are belonging to Versicolor. Okay, so like that we are having the report for the here out of 45 elements, 0.93 is the your accuracy of the model. 0.93 is the accuracy of the your test data. Okay, now we like that we are going to get the report of the entire model. Now we are going to display the visualization of our model. So here, in order to visualization of the model, we are going to import the one function is called as a tree.export. Okay, export to underscore test. We are exporting the result in the form of a text format. For that, we have to provide our model. What is the model here? Classification underscore train. Then we are going to store that value in the text underscore representation. If you print that the text underscore representation, it will display in the form of one graph. Okay, one text representation. The features, if the features are underscore 2 is less than or equal to 2.45, that belongs to class 0, and feature underscore 2 is greater than 2.45, then the feature underscore 3 less than or equal to 1.65, that is class equal to 1. Feature underscore 3 is greater than 1.65, the corresponding class level equal to 2. So here the feature 2 and the feature 3 are nothing but like petal length and petal width. Feature 0 nothing but sepal length, feature 1 nothing but sepal width, feature 2 nothing but petal length, and feature 3 nothing but petal width, and class 0 nothing but Setosa, class 1 nothing but Versicolor, and class 2 nothing but Virginica. Like that we are going to represent in the form of a text representation of the given decision tree. Okay, now we are going to represent the form of a graphical representation of our model. So for that we require the code like this. Okay, with open decision tree decision underscore tree underscore tree dot log w as output f output. Okay, f out dot write of text representation. Okay, then we are going to display the corresponding function like features names are equal to sepal length, sepal width, petal length, and petal width, and corresponding class labels are Setosa, Versicolor, and Virginica. So like that we are providing the class labels and corresponding feature names. So based on that information, based on the f-out function, we are going to represent the form of a graphical representation. Fig equal to plot dot figure. Okay, figure size equal to 25, 20, 25 rows and 20 columns. Okay, then size of that index 25 by 20. Then tree dot to plot tree. We are going to plot the tree. Okay, for the classification training, and the feature names are equal to fn, and the class names equal to cn, and filled with true. And then we have to save the image like a fig dot save figure image name dot png. Like that we are going to display our figure. So after that, if you display that one, you get the output like this form. Okay, so here the first condition we are representing the form of a tree like structure. Here already we discussed how to represent the decision tree in the form of a graphical representation. So petal length, the first length is petal length, and that is cm equal to centimeters less than or equal to 2.45. So here we are applying the concept of GINI value. So that is the value of GINI value equal to 0.663. Here the samples are 105. 105 means here the training data. The training data is divided into 70%. So out of 70% of data, that means 105 rows are there. Out of 105 rows, 105 samples, 37 are belonging to Setosa, 30 are belonging to Versicolor, and 30 are belonging to Virginica. So like that we are going to things. So first of all, we are going to check the condition. The condition is our model is with the petal length is 2.45. Okay, and then we are going this true. Okay, then all are belongs to one class. So here the GINI equal to 0.0, and the sepal. Okay, here the 37 elements are there. The 37 elements are belonging to same class. Okay, and the values are 37, 0, 0. So that means the remaining elements are not there. So only Setosa class are there. That's why we are getting the GINI value equal to 0.0. If the GINI value equal to 0.0, that means all the elements are belonging to same class only. But whereas here the GINI equal to 0.663. So that means here we are having the different combination of different class labels. The samples with different class labels. That's why we're getting the GINI equal to 0.663. That means we can split the data into further process. Okay, but whereas here the GINI equal to 0.0 only. That's why we are not going to be split the data into further process. Like that we are going to apply the things. Okay, so this is about our model representation in the form of a graphical representation. Okay, and then if the petal length is greater than the 2.45, okay, greater than the 2.45, then we are going to check the other condition, that is petal width is on the less than 1.65. So here we are having the remaining samples like 68. 0 are belonging to Setosa, 30 are belonging to Versicolor, and 30 are belonging to Virginica. So now we are going to assign the class label as a Virginica. Okay. So here, then we are going to split this process into further way. Why? Because we are having the GINI index equal to 0.493. So here we are going to check the condition. The condition equal to less than equal to 1.65. Okay. So now if this condition true, then we are going to assign the based on this condition assign the create a left node and the right node. So here the condition is satisfied. The number of samples are 31 and the corresponding values are 0, 29, 2. That means 29 belongs to Versicolor and 2 are belongs to Virginica, and the corresponding GINI value equal to 0.121. That means here the actual values are belonging to 29 are belonging to Versicolor and 2 are belonging to Virginica. So there are two different types of class elements are there. That's why we are having the GINI equal to 0.121. So the corresponding class label equal to Versicolor. Why you are assigning the Versicolor here? Because of the majority of class belonging to Versicolor only. That is 29 out of 31 elements. 29 are belonging to Versicolor. That's why the entire class label for this samples are belonging to Versicolor. So out of 31, 29 are correctly classified and 2 are wrongly classified. So that's why we are getting the GINI index equal to 0.121 and the GINI equal like that we are going to consider the right node also. So here the right node the number of samples are 37 and the value equal to 0, 1, 36. That is here the corresponding GINI equal to 0.053. Okay, that means the number of samples correctly classified as a Virginica are 36 and remaining elements are wrongly classified. Okay, so like that we are going to construct the decision tree with the help for the training data. Like that we are going to construct the decision tree for the testing data also. Okay, so here the criterion equal to decision tree classifier, the criterion equal to GINI value and max depth equal to 2, random state equal to 1, 2, 3, 4, and decision tree test decision tree underscore test equal to classification test dot fit function. For that we are providing the x test and y test data. Okay, then we are going to represent in the form of a text representation. Already we display the procedure here. Okay, here you are having the 45 elements are there out of 45 elements. Okay, based on this information we can going to be constructed in the form of a graphical representation in the form of tree-like structure. Okay, so if you draw the graph, okay, here the number of samples are 45. These 45 elements are assigned for the corresponding GINI equal to 0.648. Then we are going to split the data into two parts with the help of condition. That the condition is equal to petal length less than or equal to 2.45. They are belonging to one class, otherwise they are going to belong to other class. Okay, so here the number of samples are 45. Out of 45 elements are 13 are belonging to Setosa, 20 are belonging to Versicolor, and 12 are belonging to Virginica. So here the GINI index value equal to 0.648. That means all are different. All the 45 elements are belonging to different classes. That's why we are getting the GINI value is 0.6458. At that condition, we are applying some condition. Okay, the condition is true, then that is going to left side of the corresponding node. Okay, at a depth 1. Now the number of samples belonging to this class equal to 13. Out of 13 elements, all are belonging to Setosa and 0 are belonging to Versicolor and 0 are belonging to Virginica. So here the GINI index value equal is 0.0. That means all the elements are belonging to same class only. There is no here all the elements are purity. Okay, they all are belonging to purity. Here whereas coming to right side at the depth 1, here the GINI equal to 0.469. That means this is impurity. Why? Because of 30 out of 32 samples, 20 are belonging to Versicolor and 12 are belonging to Virginica. So there is a impurity is there. So if the value GINI value equal not 0, and if the GINI value equal not 0, then we are going to split the data into two parts once again. So that's why we are going to check the other condition. So the petal length is less than equal to 4.8. Then we are going to split the data into two parts. So here the GINI equal to 0.0, samples equal to 19, value equal to 0.0, 19, 0, class equal to Versicolor. And here see the GINI value, it contains GINI value equal to 0.0 only. Why? Because of all the number of samples are 19, all the 19 samples are belong to same class. That's why the GINI equal to 0.0. Okay, so now the corresponding class label equal to Versicolor. So here come to right side of the depth 2. Okay, GINI equal to 0.142. That means here out of 13 elements, there are two separate elements separate class labels are there, like 0 are belong to Setosa, 1 are belong to Versicolor, and 12 are belong to Virginica. So that means there are different types of different combination of different class labels are there. So that's why we are getting the GINI equal to 0.142. Okay, so if the GINI equal to not equal to 0, that means we can further split into two classes. But we are stopping at this process because of the max depth of the tree equal to 2 only. Okay, so like that we are going to construct the decision tree for your model. Okay, so here this is the model for the entire data set. So here for the entire data set, it contains 150 elements are there. Okay, for the 150 elements, 50 elements are belonging to Setosa, 50 elements are belonging to Versicolor, and 50 elements are belonging to Virginica. So the GINI index of this one is equal to 0.667. So because of GINI index value is not equal to 0, that's why we are going to split the data into two parts. Okay, with the help of GINI value. So we are going to check the one condition. That condition equal to petal length is less than or equal to 2.45. So the condition equal to true, then we are going to split the data into two parts with the help of petal length. Okay. Then based on this condition, we are divide the data into two parts. The first part contains 50 samples are there. These 50 samples are assigned for the 50 Setosa only. Why? Because 50 elements are belong to Setosa and 0 belong to Versicolor and 0 belong to Virginica. So out of 50 elements, all are belong to Setosa class only, and that's why we are having the GINI index value equal to 0.0. That means we cannot further split into further way. Okay, why? All the instances are belong to same class. Okay, that's why we are getting the GINI index value equal to 0.0. And then we are going to have the other thing is called as we are going to check the petal width equal to less than or equal to 1.75. So here the GINI equal to 0.5. Why? Here the number of samples are equal to 100 and the corresponding value equal to 0, 50, 50. Okay, so out of 100 elements, actual elements are 50 or 50. That's why the GINI equal to 0.5. Now further we are going to split the data with the help of other attribute condition, that is a petal width less than or equal to 1.75. that are belonging to one class, and if the condition is not true, then going to right side. Okay, so here the condition true, the number of elements are 54, and all after 54, 0 are belonging to Setosa, 49 are belonging to Versicolor, and 5 are belonging to Virginica. Now if you find out the GINI index of that one, we're having the value equal to 0.168. That means here out of 54 elements, there are two different types of class elements are there. That's why we can split the further way. But if you increase the max depth value equal to 3 value, we can furtherly split the data into two parts. Okay, but we are applying the condition equal to max depth equal to 2. We are going to stop here. So majority of the elements are belonging to Versicolor. That's why we are giving for the entire 54 elements, the class label is equal to Versicolor. And coming to on the right hand side, okay, the GINI equal the number of samples are 46. Out of the 46 elements, 0 are belonging to Setosa, 1 is belonging to Versicolor, and 45 belongs to Virginica. Okay, so that's why the out of 46 elements, there are different two class elements are there. Okay, all the samples are not belonging to same class. That's why the GINI equal to 0.043 is there. So out of all the 46 elements, the majority class label elements are belonging to Virginica. That's why we are assigning the class label as a Virginica. Okay, so if you see the if you see the class labels at the leaf nodes, so here 50 elements are there and 54 elements are there here and 46 elements are there. The total number of elements are 100 elements are there. Out of 150 elements are there. Out of 150 elements, only 6 elements are wrongly classified. Okay, and the remaining elements are correctly classified. That's why that means 144 by 150 elements. Okay, that is the accuracy of your model. That gives the 93%. Okay, so like that we are going to find out the performance of the model. So this is the this is the way we can classify the model, classify the data set with the help of decision tree classifier with the help of CART algorithm. It internally uses the concept of GINI index value. Thank you for watching our video. If you like the video, please subscribe my channel. Thank you.